gallons per minute. I'm sorry. Oh, we have about, we can do up to 6,000 gallons per minute, down to about 1 or 2 gallons per minute. Our flow rate capacity, again, is 6,000 gallons per minute. Again, our photovoltaic panels are on the roof of this building, can actually power up to 50 horsepower. So we can actually have, run a 50 horsepower motor or pump utilizing just the solar on our facility here. Okay, let me turn around. And Kayla's gonna swing around, and as she's swinging around, you'll notice that our laboratory here is, is a lot bigger, and there's a lot more going on. There's a lot of activity that's going on currently. We're also, because we do a lot of different testing, we test a lot of valves, backflow prevention, also irrigation products, as well as municipal products such as any kind of fixture, shower heads, things like that. Now, our lab is ISO 17025 certified. So that means that we are actually internationally certified, recognized lab. We're also utilizing that certification for our EPA water sense programs. So EPA water sense programs such as their controller testing, sprinkler testing, and also soil moisture sensor testing. We're all certified for those types of testing here. We also have 2 other additional buildings that we can't show just because of the structure of the Zoom. We can't take it out there, but we have 2 other different buildings that are constructed before this building, and those are actually our original labs. Our first building was actually built in 1980, and it was owned by Pacific Gas and Electric, our local energy company here, and they donated that company to us as a test facility, originally built to test diesel pumps. Now that building is a precursor to this building. So that building is originally our test lab, and it has a similar feature and basic setup. This facility is newer and more operated more automatically or with automation can be automated with our cell phones, or what we use is a PDA. Of course, we have a 5-ton crane, so we can carry and move things around as we need to. And our Venturis here that we have are actually mechanically inclined or physically built to be 0.5% accurate. So these things don't ever have to be calibrated because they're physically built to be accurate to 0.5% of a gallon per minute. So we have multiple of them aligned in a series, and that's how we are able to test different flows at higher or lower rates. And then we have also automated valves that we can control with our cell phones, open and close them. So that makes it easier. So it keeps our costs low and our manpower low. Then we do backflow prevention testing for different organizations and companies across the United States. Again, these were sent to us by the University of Southern California. We work in partnership with them to do backflow prevention testing and certifying. We're actually a field site for them to do these types of testing. So a lot of the other things we do is specialized testing in research and development. We'll get different products from international companies or national companies. They'll send it here, and we'll help assist them with designing different protocols to test whatever objective they're after. If it's some kind of flow, or if it's moisture sensing, or if it's electronics, that's kind of our specialty, is being a third-party research facility. We're able to provide these types of service that they might not be able to get other places. Additionally, having the laboratory allows us to do a lot of the mechanical and doing testing in-house and research with them while they're developing their product. We can do a lot of the different testing that may not be able to be performed in other smaller facilities. Again, we started off as an irrigation specialist testing company organization, but now we're moving on to other areas of water and energy savings. So that's kind of the aspect of the Center for Irrigation Technology. And Valdemar is going to show a quick video of our other 2 laboratories because we can't go out there because of the connection issues.
The Center for Irrigation Technology has been performing sprinkler testing for over 40 years and has worked with international and national companies to develop and advance irrigation systems and technologies. The Center for Irrigation Technology Sprinkler Lab was built in the early 1980s. It was designed by one of our founding fathers, Edward Norm. The pitch of the building was
Oh, I
designed
was
to
going to
allow
ask him
for
if you have
high
questions.
arching sprinklers with long throws. In this
Yeah.
short video clip, you will see one of our student technicians performing a single leg profile test. The tests are performed indoors to eliminate weather and climatic interference. This includes rain, heat, and especially wind. The purpose of this test is to gather information about how different sprinkler nozzles and system designs affect the distribution of water in a controlled environment. The data collected from this test is utilized to identify different patterns of distribution and determine where dry spots may occur. This data can be used in CIT Space Pro software, a graphical landscape design software. This software gives users a visual two-dimensional scatter plot, allowing them better ideas of where dry spots may occur in a landscape design. In addition to lab space, CIT also has 6 acres of agricultural land designated for field research purposes. Additionally, the Fresno State Farm contains 900 acres of crops such as almonds, pistachios, citrus, corn, strawberries, other field crops, and livestock. When needed, the center can tap into these different varieties of crops to further their research. CIT continues to work with different organizations to research and develop new and exciting technologies while promoting water use efficiency and best management practices. The Center for Irrigation Technology's research team continues to explore new water saving and crop cultivation techniques. Additionally, the team uses the fields for grower field days to demonstrate novel techniques and technologies. Some of the research that the center is currently involved with is nitrate reduction, monitoring technologies, and weed abatement practices, new germination practices, and ET reduction. In the video clip you just watched, you saw our students performing various sampling techniques and conducting research.
Now, these are just some of the activities that our students perform out in the field. We also do a lot of training and education. So one of our charges is, as part of the university, is to train our students and get them ready for the industry. So we do have an education program here where we train the students here at the center. They go out and have hands-on experience working in the field, and then we send them off to. Usually, they get hired right before they graduate from here, and they have a job and they're ready to go and serve the community. So that's one of our other charges. So we do a lot of we do different, basically 3 or 4 different things here. We do research, we perform testing, and also education. So one of our charges is educational outreach with different irrigation products and water and energy technology. Again, we also have sister organizations on campus, such as the California Water Institute, who we work with to develop policies and working with different agencies to identify how we can help them with water savings technology or promoting different outreach programs, also working with identifying new technologies to assist irrigation districts and also policymakers. So one of the new things that's going on in California is the Sustainable Groundwater Management Act. That's going to be a big deal coming up in the future. So as we're going and moving, transitioning into that, one of our charge here at the Center for Irrigation Technology is to assist growers and irrigation districts on understanding the legislation and laws and policies that are going to be initiated with that. But not just that, but also making recommendations on different technologies that can assist them in performing and or applying or being compliant to these technologies and these legislations. So with that, I think we're shifting over to Bill Green, and he's going to cover a little bit, and then we'll go to questions, or unless you guys have questions. Yeah, go ahead. And we were actually waiting for questions. If you guys have any questions about the lab.
As a reminder, you can ask questions through the chat or verbally if you have them. It's like no questions so far.
you know, if you need me to jump in here and do a little talking for, okay. All right, I'm Bill Green with the Center for Irrigation Technology, and I'm going to be talking about what we do. I do educational work here on campus, not so much with the students. I work with them some, but mostly we do stuff off campus with outreach events and promotion of energy and water efficiency all over California. And so one of the things that we're charged with is coming up with new and different ways of delivering these messages that are interesting. And of course, through the last year or two, because of the COVID-19 restrictions, we've had to change how we go about, just like this virtual academy here. We've had to go to virtual and webinars to be able to deliver our messages of energy and water efficiency. So behind me, we have the Mobile Education Center trailer. And I don't know if you can see it. I can't see what I'm looking at here. So anyway, it's the mobile lab we used to deliver these messages in the field. Well, we've moved it into our wet center here, at least part of the time. It's not here all the time, but we moved it in and we connected directly to it, and we can still deliver our messages via webinars and online camera work. And we have a lot of time here, so why don't we go ahead and do a tour of this Mobile Education Center. We'll talk to you about this, and then I'll bring up some more things that we're working on that we're starting in the new, not too distant future. This is a working pump station as a whole. And so you have working equipment, and we do live demonstrations. And we found these to be very effective, more than just the PowerPoint. I do that too, but I do it in combination with a live. And then we also now are doing a lot of video work with all our new cameras and that sort of thing. So on this trailer, we have different things here. On the left here, you probably can't see it very well. There's a water tank there. But the water tank flows in, and we have a 5 horsepower submersible pump in this plastic can right here. So that's the pump I use a lot to deliver our workshops and our demonstrations. That water flows into there, and then when we turn this on, and we will demonstrate this in just a little while, water flows out of there, and we have a mainline check valve, a agricultural check valve that we use for with a low pressure drain and air vacuum relief vent. For our chemigation and fertigation workshops, we sometimes bring that into play. We have a pressure gauge right there. As you can see, the pressure gauge is up on top, and there's a transducer there, and that takes the signal back to our computer. So we are able to take information in real time and put it on the screen to deliver our educational message. So that's the first component. Then water flows on down the line here, comes around the corner, and we bring the water back, and it flows back towards the tank. So we're pumping in a circle. And so it's actually a miniature of this entire wet lab that Calmine was describing, that we have pumps and valves and lines and things, and we're pumping in a circle all the time. Normally the water would go on out to whatever target you're trying to irrigate, but for in this case, we're just pumping in a circle. So the water comes back here. We have a second pressure gauge with transducer here, and I'll discuss that a little later, why we have that. Water flows down. We have a flow meter here, and this is the flow meter that gives us our reading. We have a second flow meter over there. It's just a different brand. We don't advocate anybody's individual brands here and stuff. We're just advocating using the right technologies that you can be as efficient as possible with water and energy. And so that's what this trailer is used to, message it's used to deliver. Water flows down. We have a pressure regulating valve here, or a flow regulating valve. I just open and close it by hand, and then water flows back to the tank. So we're pumping this circle. Now, the reason this is important, or the reason we found this to be very effective, is we are able to deliver these messages in real time to growers. And through our advanced pumping efficiency program, which we've been running for the Pacific Gas and Electric, it's the local PG&E is the local electric company. We've been running now for over 18 years. One of our main charges is to deliver educational messages and outreach to growers and to other people that are moving water in the state. Of course, a huge chunk of the connected load in California is used to move water. And so that means it's very important that we do it as efficiently as possible. This year, we're back into the second year of a drought, and it's one of the most severe droughts we've seen in the last 100 years. I think it's the second worst drought maybe in history since they've been recording these things. And so we're in major trouble here in California. So anything we can do to try to be a little more efficient with water and energy, we're going to do. Obviously, with energy costs, those are going up, and we've dealt with wildfires and all these other issues here on campus for many years now, and we're dealing with them all over California. Now, I'm a farmer myself, and so it's affected, the smoke in the air has affected the results of my crop and my production. It's affected how I apply water and when. It's affected everything. And so that's the kind of messages we're trying to deliver through these talks. We also are able to move water through the system again. We'll look at it again here. I'm able to divert through this other pipe right here, and then water goes into this end suction centrifugal pump. We call that a booster pump. And so we're able to create additional pressure. Pressure costs money, and we're able to put all that on our screen with a cost per kilowatt hour, which you're paying to your power company, and show what those kind of costs are and demonstrate that in real time. So, and we're able to run all this equipment at one time and get that information. Additionally, on this trailer, we have a couple of things right here. You got that? There's variable frequency drives here, one for each pump. We've got one for the submersible on the left, one for the centrifugal booster pump on the right. We do talks on VFDs, and because there's a lot of those being installed now on pumping systems here in California. VFDs were not a major thing, say 10, 15 years ago, but now many pump systems have them, and many more are putting them in when they have need not to run use the entire horsepower of their pump, but actually slow that pump down to use less energy. So they do that. We also have a smart meter here. Now, the smart meter is key because this is how people pay for their energy. On your house in California, I'm sure, and other places in the country, you have meters, and electric meters read out, and every month that total kilowatt hours you use goes up, and you pay based on that for your energy costs. So we're able to use this not only to get total amounts, but also to get real-time energy usage. So if you went out at your house and you're looking to see what your meter is reading, it'll say KW as it scrolls through. KW is how many kilowatts, how much energy you're using in real time. So that you can actually then flip on the air conditioning or some other major appliance in the house and come back out and read it again, and you'll see that number go up quite a bit. You're using a lot more electricity then to run whatever implements or whatever things you're doing in your house. Same thing with the farm. And so we're making all these points through the Advanced Pumping Efficiency Program to try to make people more efficient and more cognizant of where they're spending this money. Energy costs on my bills here in California have gone up about 30 to 40% over the last 8 or 10 years or so, maybe even more than that. And demand charges for delivering that electricity has gone up this year too. And so those are all new messages that we are delivering to the public at all times. One of the things we found through through the COVID issues this year is that these webinars are actually attracting a larger audience than we used to get for our live events. Live events, if we got 20, 25 people, we're doing well. But quite often for these virtual events, we're getting upwards of 40, 50, and we've had as many as 250 for some of our field day and things like that we did here a few months ago. So we're getting some very good audiences, and people are enjoying them. And I think that part of the reason is they used to have to drive to a location where we'd have the trailer and they would come and they'd sit there. And if it was a hot day, it was not real comfortable outside. Now they can do all this from the comfort of their house or even their car. They can watch it on their iPad or on their phone, and they can get a pretty good idea of what we're doing when we're talking about these different projects. One of the things with the trailer that makes it so effective, I think, and pumping systems in general, is our ability to deliver it and make it meaningful and try to relate it to what people are dealing with in the field all the time. I think this is a key issue. So often with presentations, there's a PowerPoint and some graphs and lots of information is delivered, but it's not explained step by step of what you're seeing and be able to change things in real time to be able to see differences that occur in the field. And we can do all of those things with the trailer. So I think what I'm going to do right now is I'm going to go ahead and fire this thing up, and we'll put it on screen and show you what we're looking at, just to give you some basis for all this. It should be able to explain kind of better what I'm talking about. So let me go ahead and check in just a second, because my computer went to sleep on me again. I'm sorry. Is there any questions right now? Nicole, is there nothing yet? No questions?
In the chat yet.
Okay. All right. Just thought I was hoping to get a few. We'll see if we do. Okay. Now, before we show this screen, leave it on the trailer. Okay. So what I'm going to do is this. I've got this set up. Let me explain what we're going to do here. Kind of winging this now. We're going to fire up this first pump that's in this plastic can here. And you'll see pressure start to go and things like that. We'll show those. And then I'm going to fire up the booster pump with it. So I've got this routed right now with my valve up there. So it comes through this pipe into this end section centrifugal booster pump here to create additional pressure, and then runs through the system back. So let me fire that up first to show you that. And then we'll go to the screen that has the information that we're dealing with on that.
Hey, Bill.
Yes.
We actually just had a question come in.
Okay.
Where do you get funding to have the mobile set up and even other aspects of the center?
Okay. Well, funding comes from a lot of different sources. It's a good question, though. The Advanced Public Efficiency Program I brought up is funded through PG&E, Pacific Gas and Electric. And also we've worked with Southern California Edison, the other major power utility here in the state. There's a third one, San Diego Gas and Electric. We've worked with years ago a little bit, but they kind of do their own thing. But Southern Cal Edison and PG&E are the two main power companies in the state of California. And they have funding through the Public Utilities Commission of California for energy efficiency projects. And so this falls under that umbrella. And we're working under what they call the Workforce Education and Training Programs right now. This is new this year, actually, for us. We've changed funding sources, still through CPUC grants, but it's changed this year to a different area of PG&E than we worked with in the past. But all the same, this is continuing on, and that's the funding source there. Now, for other projects, a lot of times they're funded, and maybe Calmine can come in and talk about that for a second.
Yeah, all of our other funding is from local government and also from different national organizations. You know, we've gotten funding from USDA, we've gotten funding from California Department of Food and Ag, State Water Bureau, the Bureau of Reclamation, Department of Water Resources. So it comes from a lot of different funding for research. As far as our work testing here, a lot of it, some of the smaller organizations or smaller manufacturers, when they're developing their research and development projects for their new product that they're trying to market into the California market, a lot of it is through small business loans or grants that they're getting to develop these technologies. So we get our funding from a lot of different sources. Some of our research is funded by private organizations. So different manufacturers will fund part of the research, and then we'll use it as like grant match to perform a larger research project. So our funding here is actually varied depending on what we're doing or what research we're doing. Also, CIT is we're probably one of the few organizations on this campus that is almost self-sustained, basically finding grants and whatnot to fund our staff. So.
Okay.
Thank you.
Thank you for the question. I'll add on a couple more things. We've recently entered into, or we're in the process of entering into some other agreements with the Department of Pesticide Regulation here in California to do chemigation, fertigation type, mainly chemigation workshops and live use, because we have another MEC much like this that we built years ago that has working chemigation equipment on it. And so we're going to be doing some of those live events too. Both as webinars and perhaps in-person events for their the County Agricultural Commission staff, and also for farmers too. So that's another funding source. We're just recently also, we just started working on we're a subcontractor for another grant through the California Energy Commission, which is another energy and commission here in California besides CPUC. They work under CPUC. But anyway, the CEC grant is just come through, and we're going to be doing some educational webinars on permanent load shifting. Now, permanent load shifting is trying to get people to use electricity at the times of the day when there's ample electricity, as opposed to trying to pull excess power when energy reserves are very low. So, for example, in PG&E's territory, until this year, before the peak time of day when there was the least amount of electricity available, was noon to 6 Monday through Friday. And so you had all weekend long, you were off. That's called, was considered on peak or peak time, and they charge you more for the electricity, quite a bit more during that time. But people still have to use some. But so that was one of the things that this other grant will do, was how do you get off of that? Now this year it has changed. The new program through PG&E, the peak time is 5 to 8 in the evening, 7 days a week. So they don't want us using as much electricity from 5 to 8. And the reason it is because of the advent of all the new solar installations. There's so much solar power being delivered now in the afternoons that we're no longer short of energy anymore in the middle afternoon. So even though it's hottest part of the day is 3 o'clock in the afternoon, and in Fresno, when it gets 105 or 110 and there's air conditioning running, and all, usually if it's hot here, it's hot all the way up and down the San Joaquin Valley and up in the Bay Area and LA too, a lot of times. So that's when the peak time used to be. But with all the solar energy, they aren't short of energy anymore, but they are short in the evenings when solar becomes less effective from 5 to 8. So now they're trying to get us to shift our loads, the time we use electricity heavily, from that 5 to 8 period into the other 21 hours a day you have when they aren't short of energy. So for irrigation purposes, that means hopefully if you're on drip or something, you have a timer and you can go ahead and shut your pump off. For example, on my place, I mean, the pump shuts off at 4:58 p.m. in the afternoon, and it turns back on at 8:02 p.m. in the evening, so I can avoid that higher cost during that time. And they've also charging greater demand charges, which is the load you have on that pump. It's charged in real time now. So if you get hit, if you run on that on-peak time, it's going to cost you a lot more money than if you stay off of it, especially with larger horsepower pumps and installations like that. So those are the kind of messages we'll be delivering through that other grant. So that I just wanted to add on to what Calvin said. We have all these different sources, and that comes into play as far as where our funding comes from on these things. So there's a lot going on with the drought and everything right now. So, okay, let's get back to our trailer again. Unless there's another question, I don't see anything. So I guess we're okay for time being. If another question comes up and you have a question about something Calmine talked about, stop us and we'll talk to you about it. Anyway, so I'm going to fire up this trailer right now. I'm going to start the pump in the plastic can right there first. And Valdemar behind the, he's producing this right now. He's staying on track of this. You're probably getting camera work there. I'm going to hit the start button and we'll see that thing fire up. Okay, so I fired that first pump up right now, and you can see there's pressure on the pressure gauge up there. Okay, there's the flow meter has got a reading now. So he's getting on that. I'm going to give it time on that flow meter, and our flow meter is turning here. That's a propeller flow meter. I don't know if you can see that. That's good. So you see that one pump is running. However, I've got the water moving through that booster pump, and so that needs to run also the way I have it set up right now. So I'm going to start it now. Okay. So now we have both pumps running. We have pressure on both the different gauges. You have the pressure gauge up there that's reading about 40 pounds. Got that okay? And we have a pressure gauge here that's reading at about 76 pounds. That means we're getting 40 pounds pressure out of the submersible pump in the plastic can, and we're getting an additional 36 pounds, that's why a total of 76, coming out of our booster pump. Okay, so between those two things, we're getting a total of 76 pounds. So that's what a booster pump does, is boost the pressure, basically. At the same time, we're getting a flow rate reading right here. It looks like it's reading about 120 gallons a minute. That's coming off of our flow meters. Let's go to the screen that shows all this in real time. And Valdemar will switch that up. Now we're on screen. I don't see it on here, though. It doesn't matter. Oh, okay, that's right. That's all I got. Okay. Okay, so anyway, the screen here shows the different levels we've got from each pump. These are called pump curves right here. And they show the combination of pressure, which we convert to total dynamic head and feet. So it's pressure times 2.31. So right now we're running about 40 pounds of pressure. If you, or I'm sorry, 76 pounds of total pressure up here times 2.31 probably equals about 176 feet of lift on this pump. Along the bottom, we have flow rate, 0 to 200 gallons per minute. Right now, currently, we're running right about 98 or 100 gallons per minute. You can see our numbers bounce around a little bit, but that's showing the actual what's coming out of these little pumps. And these are just little 5 horsepower pumps. They're not as big a pumps as what you have in the field in most cases, although there's some this size, but they still make the point when it comes to energy efficiency and the cost to move water. Now, along the bottom here, I plugged in some numbers, and you can probably see my cursor along the bottom here. Hopefully you can see this on your screen. First, I said optimally, we should be about 60% pump efficiency. That's usually considered, for a small pumps like this, that would be considered very good. Bigger horsepower pumps, maybe hopefully 65 or 70%, and that's wire to water efficiency. How much electricity is coming in off the power line versus how much water is coming out of that pump. Okay, so we have that. I also plugged in a cost per kilowatt hour. It's right on the bottom there, and it says 0.19 or 19 cents. This is how much I'm paying on my farm right now for off-peak power to irrigate my vineyard. So I'm using that as an example. And that's off-peak. That's not the expensive time of day. Expensive time of day goes to about 35 cents. So, and maybe even a little bit more during the summer. So depends. There's different rate schedules and stuff like that. So that's what I plugged in there. Next, we have, I'm going to skip over one number right here. It says 3,600. That is the RPMs, the revolutions per minute on the pump shaft that we're running currently on this submersible pump. It's full speed on that pump, 3,600 RPMs. Over here, I'm going to skip over a little ways. It says 1,800. Well, that's the RPMs on our booster pump. It runs at half the speed as the other ones, revolutions per minute. It's just a different type of pump setup. But anyway, it's running 1,800. It is also at full speed. Now, based on those numbers I plugged in there and stuff, now we can see on our bar graphs here what the pumps are doing in real time. And this is both pumps together. Oh, before I go to that, I should go back to this. Remember I mentioned that we had 40 pounds of pressure on the first pump? Well, this is the condition that's coming from the submersible pump right here. If you take 40 times 2.31, that'll equal about 94 feet of total dynamic head. The booster is boosting the pressure from this red line to this blue line right here. It's creating the additional pressure, and that's what gives us the total TDH of 178 feet, which is about 76 pounds pressure. And that's why there's a difference there. So this is the submersible pump's operating condition currently. With the booster pump, that's what it takes it to. So that's why we're looking at that. Now, if we look at our flow rate here, it shows it's running about 98, 99. You see the numbers bounce a little bit. That's from our transducer readings. Remember, the flow rate is coming from our flow meter in the middle, okay? And so that's where we're getting that flow rate. The feet of head is coming from our pressure gauges times 2.31. Okay. So that's why we're running 98 gallons a minute with about 179 feet of lift. Now here it shows the actual percentage of overall pump efficiency for each individual pump. For the submersibles here, it's running about 56. Numbers are bouncing around a little bit, but that's pretty good. And then we have the booster pump, and it's running about 65% efficiency. Now, between the two, we're running about 60. Well, if you remember right, when I first started talking about this bottom row down here in the bottom left, I plugged in the optimal as 60%. So we are running exactly where this pump was designed to run optimally. Both of these pumps, they're set up to run together most optimally, and they're set up to do this condition. If the farmer required a condition like this, these two pumps work well together. Now, that doesn't mean that pumps stay that way. That submersible could be a deep well pump or something, and that could change because water levels change, particularly during drought years like we have in California right now. So, for example, changing that will change the output of these pumps. Oh, one other thing I forgot to mention here. Based on the cost per kilowatt hour of 19 cents, so we're running off peak, and the amount of water we're pumping with the pressure and everything, and the efficiency, we're able to tell you how much it's costing us to pump an acre foot of water right now. That's about 325,851 gallons. So 1 acre feet is how we measure that in agriculture. Right now, it's costing about $58 per acre foot. You notice the optimal is about the same. Well, because we're running at 60% efficiency and the optimal is about 60%, it's about the same. What's going to happen during this drought year this year? What is an example of what will occur? Well, unfortunately, because we don't have the recharge of our ground water aquifer, water levels will drop. So that means we'll increase the feet of head. Well, that's the same thing as closing a valve on a pump. It's the same thing that happens. So I can mimic that by closing this valve. I may have gone a little too far with it, but what the heck? It's an example of what happens, especially over a few years period. Okay, so let's take a look at our chart now. So we've moved left on our curve because it's the same thing as creating more lift on that pump. We were at 175 feet or 176. Now we're at 225. It's like the water level dropped 50 feet or something like that. Okay, so you can see where we were on this. Now we're here, but look what happened to the flow rate that was about 99 gallons a minute. Now it's about half that at 52, 53 gallons per minute. The efficiency of the submersible is no longer on its most efficient point on the curve. It's dropped off, and it's 42% efficient. The booster pump has dropped from 65 down to 52%. Between the two, we're running about 46% efficiency now between these two pumps. These pumps did not wear out. The water level changed. Water level dropped. And in drought in California, this is some of the things that's occurring now. And so this is the kind of examples, real world examples, we can give to farmers to show them what may be occurring. Now, let's say, I'll use my own farm as an example. On my own farm, I have a certain flow rate and pressure I need to create out of my deep well pump to run my drip system on my raisin vineyard. When the water level drops significantly, now I'm getting less flow rate and less pressure to the field because the energy of the pump is being used to try to lift the water farther from underground. Consequently, I'm going to see less flow rate and less pressure in the field. That could affect the uniformity of my irrigation system. Or it certainly could affect how long I need to run the pump. Without a flow meter and things like that, I wouldn't know those things unless I saw this occurring in real time. Now, this example I put on the trailer here was a little more abrupt than what I have on my farm, but there's places here in the San Joaquin Valley where the water levels vary by 40 or 50 feet from April through August, and pumps fall off. But usually in the wintertime, they recover. Well, that's not happening on a drought year like this. They're not going to recover. Water levels are going to continue to drop down. And Cal mentioned earlier the Sustainable Groundwater Management Act. Those are some of the things that we're having to deal with California regulations. I know there's similar things in the Midwest with the Ogallala Aquifer and other places in the country too, where water is short, especially in the Southwest and the Midwest of the United States. It's probably where it's the biggest problem. So this is just an example of the kind of thing we can do with our equipment to make those demonstrations come alive. We can also show when water comes back, how it changes things. Okay. So you can see all these different things occurring all the time. Now, this is just a very small show of what we can do with our equipment. We can do all kinds of things. I can slow the pumps down with the variable speed drives. I can show other effects of when your irrigation system filtration is plugging up. All these different things we can show and make these talks come alive for growers, and they've been very effective. And in a couple hours, they got a better understanding of what they're up against. And when they talk to their pump dealers and the pump people that do the work, they can hopefully ask intelligent questions and work with that. And so we've been doing this educational work for 18 years, and yet there's still a tremendous amount of work to do. We get new students all the time to our classes. They're free. And so that's one of the things that we like to do, is we like to offer free classes to farmers or students. I work with junior colleges. We work with the universities, whoever we work with.
It's up on us over here, Bill. Bill, can you hear us? Bill? Sorry, everyone. Give me one moment. Thanks for your patience, everyone.
Yeah. Can you hear us okay, Nicole?
We can hear you. No video, though.
Okay. Sorry, we lost our Wi-Fi for a second. We don't know what happened.
No worries.
Yeah. One of the things.
Here we go.
One of the things with live broadcast. Did they hear most of what I said before we cut out, or was there a loss there?
I think you were out for a while.
Oh, we were.
Yeah, at least a minute or two.
Okay, well, a minute or two is not too bad, but anyway, just was trying to make the point of why we think live webinars and things like that are so effective. They're not effective when you cut out like this, obviously, but we haven't had that. We've done quite a few of these, and we hadn't had that problem completely. So, anyway, I'm glad you're back now. I had a few slides here, real quick. Are you on the?
Did you guys have questions?
Yeah. Was there any questions to Nicole?
No questions in the chat. Do you guys have any questions? Feel free to, as they come in, to put them in the chat or ask verbally.
I have a couple slides here too, and the kind of things we talk about with our programs and stuff, and this slide shows a lot of those different things that we talk about while we're doing our talks for basic pump efficiency, but we go into a lot of other subjects, irrigation efficiency and all kinds of different things. And so we are going to do a series of those. And I wanted to put on here, if anybody's interested, these are free. You can register at the PG&E website right there. And you have to sign up with them and stuff. But, it's we get people, actually, even though PG&E is a California company, and most of people we get are from California. We've had people from every continent except Antarctica. I think we haven't got one of those yet, but we've had every other continent coming on to some of these talks lately. So we're getting people from all over the world, and so you can sign up for these, and they're the registration is www.pge.com/energy classes. And you'd have to walk through it, but it'll show some of our upcoming classes. And our new second half of 2021 is coming up. We have quite a few different new subjects we're going to be talking about. And if anybody's interested in that, they can log on and just, and you can participate same way we are here, where you can ask questions. And most of them will be live. Some will be, well, they'll all be live, but some of them will be using videotape when we go out in the field, a lot of times on the campus farm, much like the video that Valdemar and Calvin showed you earlier. We will have videos like that we can show you, but also we do the live events like this too. And we're just getting set up, and it's unfortunate we dropped off today with that signal, because we're just getting set up with a new computer and things, and we think we're going to solve some of these issues that we've been having. So that's at least what we're working on right now. So we're continuously trying to make these webinars better all the time and improve them. So I just wanted to make that point. If there was any other questions for myself or Calmine, we're both here. So I guess we don't have any questions, huh?
Any questions?
Well, you can always contact us through the Center for Irrigation Technology. I should have put the contact information on one of these slides, but you can contact our main office at 559-278-2066. And if you have questions about the lab, or you want to talk to Calmine, maybe there's something, a project that you guys would like to get third-party certification, I'm sure they can call you.
Yeah, they can call me, or they can call directly to the number you just mentioned, and then, or shoot me an email, you know.
Yeah. So in fact, Nicole, we can supply you that information if you want to give it out to the attendees afterwards. And
Yep,
so,
I included your bio and email address in a file I sent out to everyone, so they should be able to access it.
Yeah, please feel free to contact us. That's what we're here for. And if there's any information they need. So I guess that's about it.
Last chance for questions if anyone has them.
I just wanted to say thank y'all for your time today.
Oh, you're welcome. Glad to do it anytime.
All right, well, if there are no more questions, I think that wraps up our webinar or our tour of the Center for Irrigation Technology today. Thank you guys for tuning in to this session. And again, a big thank you to Bill and Calmine for leading this wonderful tour. Our next session, which is Soil Salinity, an Old Problem with Modern Solutions, will start tomorrow at 12 p.m. Eastern. As a reminder, each session has their own unique Zoom link. Again, thank you both for leading this great tour of your facility and talking about the different programs and funding you guys receive. And again, a big thank you to our sponsor, Rainbird. Thank you, guys.
Thank you. Bye-bye.
Bye.